Okay, so we're going to do completing the square in this video. First thing I would ask is, what is completing the square? Because it's pretty, unless we actually know what we're trying to do when we complete the square, then there's not really any point in doing it or trying to do it unless we've got some clear idea. The thing is with quadratics is that it's often useful to write in a different form. The normal form of a quadratic, the typical form that we have of a quadratic is of this type. But it is sometimes good to actually have factors, as we've seen, because that will tell us where it crosses the axis if something factorizes. But another useful form is to write it in what's called completed squared form, which is to write it for some different values of p, q and r in this form. Okay, so the thing is, it's always possible. It's always possible to write a quadratic of this form into this form, and it's useful for a number of things. And for example, it will tell us, to help us identify where the line of symmetry is and where the actual vertex is of a quadratic. So it's handy for a lot of things to be able to actually convert from one to the other. One of the reasons why, of course, is if you look at this, so x occurs twice, whereas in the completed squared form, x occurs once, which is sometimes quite useful. So it's an important thing to be able to do. That's it, really. So without actually doing any questions, we can write that is equivalent to and minus. Okay, they're exactly the same thing. So, for example, if you put 0 in here, you get 0 squared plus 0 plus 7. So that gives you 7. If you put 0 in here, you'll get 16 minus 9, which is 7. If you put 1 in here, you'll get 1 squared plus 8 plus 7. So that's 1 squared plus 8 plus 7. So that's 9, 16. If you put 1 in here, you get 5 squared minus 9 is 16, and so on. The name for such a thing here is called an identity. And that's what we're doing. We're just finding an exactly equivalent expression, just written in a different way. That's what we're doing when completing the square. Okay, so how do you do it? Well, before I talk about how you do it, there are two important rules that I like to use when it's basically to square out brackets is a very important thing to be able to do. So we should be able to easily write this without any fuss at all. For example, you should be able to do these at the same speed I'm doing this now. Or even, let's stick a fraction in. Okay, and we can do this merrily along. That's 7 over 6 squared. That's equal to okay, so that's the kind of, we need to be able to square out brackets like that. Have a look at my video on this if you want to. I'll have a video on how to quickly square out brackets. Basically what we're doing is we're using these quick hardwired rules rather than making a big fuss of it. To square a bracket, we can use that. Might be good to rewrite it with a negative in. for that. Right. So if you thought, oh, I'm not sure about that, I like to use, this method that I'm used to, drawing out grids or whatever, it really would be useful if you practice just trying to multiply out brackets quickly like that, multiply out square and brackets quickly like that before you move on to completing the square. Okay, because it's important you can do that. Okay, so now let's do an example. So let's suppose I wanted to complete the square for something really simple like x squared plus 4x. Okay, well, what I need to look at is when I square the bracket, I'm going to need a 2x, so I need to half that number inside the bracket to actually compare it to something. So let's consider the thing squared. I don't know what happened there. X plus 2 squared. Well, we can, as I said, we need to be able to do this pretty good. Minus plus 4. That's it. So if we want just x squared plus 4x, we need, in order to compensate for this 4, we need to take away 4. So if we're completing the square for x squared plus 4x, we basically write out the x plus 2 squared take away 4. They're identical, and this is the completed square form here. Okay, let's do another example. X squared minus 6x minus 7. Okay, so what we're going to do is we're going to consider the expression with this 6 halved. So we have x, we're going to consider x minus 3 squared is, because we're going to get the x squared minus 6x that we've got here, but we're also going to get plus 9. Okay, so if we want to complete the square for it, we have, for the x squared minus 6 bit, we can replace that with x minus 2, so x minus 3 squared, take away 9 because of that 9 there, but don't forget that's just the first two terms we've got there. So don't forget the 7 at the end that we've got here. So that comes to x minus 3 squared take away 16. And what I tend to do when I've done this, because it's amazing how you can get mistakes with this. In the head, I would be kind of checking that these make the right thing. So I might be, without writing it out, multiplying this out, 8x squared minus 6x plus 9 minus 16. Does it give me that? And yes, it does. So I probably wouldn't write that out, but something that would be scanning through this to see if actually we can get from there to there. Okay, let's do another example. Looks the same type of thing, but it's going to be significantly harder because this is odd, which is surprising how, because we've got to consider fractions, it's going to make the question that much harder. So what we need to do is consider the square of x plus 3 over 2. Okay, so that gives me x squared plus 3x, should I say? Plus 3x plus 9 over 4. Make sure you square this thing properly. So then, when we're looking at this expression that we want to complete the square, we have x squared plus 3x minus 1 equals to x plus 3 over 2 squared minus 9 over 4. That's basically replacing that with that. But I've still got the take away 1. Okay, and we need to take care with the fractions that we work with the signs properly. For the common denominator. And then minus 9 take away 4 is minus 13 over 4. And talking about the check, again, as I say, I don't tend to write this out. I tend to do it in my head and just see if things work out properly. And it's really it's often this last term that we need to check is right. So looking at this, we get 9 over 4, take away 13 over 4, which is minus 4 over 4, which is minus 1. So it feels right. Okay, let's go up the difficulty a bit. What to do if we have a number in front of the a, in front of the x squared? In other words, a is not equal to 1. That can also be an added complication, where it is an added complication. Now, some people do this different things here. Some people take 2 out as a factor of the whole thing, like that. And some people just take it out of the front bit, like that. I tend to do that because we can then just leave this alone and not have, because in the end you have to multiply the whole thing out by 2 anyway. So I tend to leave it do it like that. At least if I'm just asked to complete the square, not solve an equation for it, using completing the square. So there we have that. So this is the bit I'm going to complete the square for here. Okay, so the thing I need to consider is this number half, so it's x plus 1 squared. So that equals to x squared plus 2x plus 1. So that means that the completed square bit here, I'm going to write it up here, you're going to need to be very careful with the brackets, because we've got 2 bracket the stuff that we're going to do for the completed square, which is adjusting at this, take away 1 at the end. So be very careful to be disciplined, don't rush it. So now we're just completing the square of this. We've done the squaring bit that helps us do it. So that's x plus 1 all squared, but I need to take away 1 in order for x squared plus 2x to be equal to this. So then that equals to 2x plus 1 squared, take away 2, take away 1. So I'm multiplying out the brackets. There's 2 times this bracket and 2 times the 1. So I've only got 1 bracket left. And that's 2x plus 1 squared, take away 3. And as I said before, I might be checking certainly the last term, because as long as we've been careful enough, it's often the last term that's the one that you're going to get wrong. If we look at this, we get, square this out, we get the 1 times 2, take away 3, does give me minus 1. The middle term will be 4x, because I'll have a 2x here and a 4, so it feels right. Okay, so let's do another couple before we move on. Suppose I have minus x squared plus 4x plus 1. Okay, well, basically a is minus 1 now, so I can just write that as taking the same idea as before, taking out a factor of minus 1 of just the front bit. Well, you can do the whole bit if you want. I just tend to prefer just to do it to that bit, plus 1. And of course, it seems a little bit infantile to put a minus 1 in front of there, so I'm going to just leave that as a negative. But of course, it's not wrong to put that 1. It's a little bit immature. Okay, so I'm going to write it like that. Okay, so now I need to consider I need to half this. Keep the sign the same, by the way. So we've got a negative here, so we're going to keep the sign the same. So I'm going to consider x minus 2 squared. We can square that quickly. That's x squared minus 4x plus 4. So going back to putting that in this bit here, I get negative, don't forget, negative plus whatever I do with my completed square, plus the 1 at the end. Well, x squared minus 4x using this can be replaced with x minus 2 squared, take away 4. So that gives me, now multiplying out the negative now, I get negative x minus 2 squared. Minus 1 times minus 4 is plus 4, plus 1. So that gives this as minus x minus 2 squared plus 5. Now you'll often see that written with the number in front. If you see an expression like that, you might see it written that way with the number coming in front of the bracket, because then you've got a positive at front. Let's write it if you like, you don't have to write a plus sign. So you might see it written like that instead. Okay, so, and again I would probably prefer to check this. We can see that the minus x squared, we're going to get minus 4x when we multiply this, so we will get plus 4x when we change the sign. But we just need to check the number again. Squaring this will give us plus 4, but it's minus that, and I'm pretty confident it's right because it matches this. Okay, one more. So we have a minus 3 this time. So I'm going to take that minus 3 out in front of these two bits here. So that's minus 3x squared, take away 2x plus 2. Okay, so what we're going to do is we're going to half this number here and consider that expression. X minus 1 squared is the same as x squared minus 2x, which is what we're after here, plus 1. So when we complete the square, we get minus 3 x minus 1 squared, but we're completing the square for that bit, so it's take away 1 because of that, plus 2. Now multiplying out carefully, we've got minus 3 x minus 1 squared plus 3, because it's negative 3 times minus 1 plus 2. So that gives me, and again I will write the number in front this time, so we've got 3 plus 2, which is 5, take away 3, bracket x minus 1 squared. Okay, it's in completed square form because we've just got a square expression combined with a number. So again, I'm going to check. I'm pretty confident the minus 3x squared is correct from this. I'm going to get minus 3x squared. I'm going to get 6x because I'm going to get minus 2x in this expression, which I'm going to times by minus 3, which gives me 6x. So the number, which is the more likely one to be wrong, we don't get plus 2 when we multiply this stuff out. Well, we're going to get plus 1, times that by minus 3, which is minus 3, combined with the 5 does give me 2. So I'm pretty confident, having scanned it through, that that is correct. So that's given a few examples of completing the square. Before I move on, before I can finish, so if I consider the first example I did, x squared plus 4x, which can be represented with a rectangle, which is x plus 4 times x. So let's make that the plus 4 bit here. Let's make the square bit here. Okay, so this is x4, so therefore of course that's x plus 4. And this is the x bit here. Suppose I were to cut this part in half. Okay, so I cut a little strip out of this, exactly halfway around, so that it's 2 there. Okay, I'd then be left with a rectangle like this, which is x plus 2. If I then rotate that, remember this is an x by 2 strip here, so I can fit that along here because it's x from here to here and here to here. So I can kind of rotate that and fit it onto the side here. So like here. So now I have 2 here, I have a 2 there and 2 there. So I basically almost have an x plus 2 square, but an incomplete x plus 2 there. So what I'm missing is that we have a square of x plus 2. So the missing bit is this, so that hence the word completing the square. So there's the word, that's completed square with 2 by 2 square. And if you look back at the question, that's where the 4 comes in. So that's a nice visual representation. It's explained better by other people elsewhere, but I still think it's worth talking about. But hopefully you find the video generally useful. There is a formula for it, but I think it's only good to use that formula when you've really got used to completing the square. And the formula goes something like this. Some people teach it exactly from the formula. But if you've got something like this, then the completed square is x plus b over 2 squared plus b over minus b over 2 all squared. That's the adjusted bit. Plus c. That's the formula for it. But hopefully, if you've practiced this enough, that formula might, if you're going to use it, start to make a bit of sense, because we halve this number. And in order to kind of adjust for the fact that we're going to get this b squared over 4 bit, or b over 2 all squared bit, we need to take it away. Okay, hope you found it useful. Bye.